All right, let's be honest. You've been there, right? You solve a trig problem, and the answer is something like pi over 3. And you're just staring at it thinking, okay, great, but what does that actually mean? Well, this one's for you. Today, we're going to learn how to translate those abstract radians back into the degrees your brain actually thinks in. It's the key to making sure your math doesn't just work on paper, but that it really, truly makes sense to you. So here's the game plan. First, we're going to talk about why this is even a problem. Then, I'll give you the one simple key you need to solve it. We'll walk through a few examples together. I'll point out the #1 mistake people make so you can avoid it. And then we'll wrap up by looking at how your phone's GPS is doing this exact math, like all the time. Okay, so what is the big deal here? Well, the thing is, in higher math, and especially on your calculator, radians are kind of the default language for angles. But let's face it, most of us, we think in degrees, right? We think in 90-degree turns, 180-degree flips. So when we see radians, it can feel like trying to read a foreign language without a dictionary. And that leads to this huge question, right? Your calculator spits out an answer in radians. How in the world do you know if it even makes sense? How do you do that quick gut check, that sanity check, to feel confident that your answer is pointing in the right direction? What you need is a translator. I like to think of this as a two-way bridge. Now, you've probably already learned how to cross it one way, going from degrees to radians by multiplying by pi over 180. But today, we're focused on the return trip. We're coming back home, turning those weird-looking radians back into the degrees we all know and love. And to do that, we just flip the toll, so to speak. We multiply by 180 over pi. All right, so let's get to it. Let's unlock this conversion. It really boils down to one simple, super powerful formula. This is the key that makes the whole translation process work every single time. And boom, here it is. It's that simple. To get your answer in degrees, you just take whatever your radian measure is and multiply it by 180 over pi. And you know, this isn't some random magic formula. It comes from one core fact of trigonometry, that pi radians is the exact same thing as 180 degrees. All we're doing here is using that fact to our advantage. And here's the really cool part, the part that makes the math so satisfying. You know how most of the common angles, like 30, 45, 60 degrees, are written with a pi on top when they're in radians? Well, that's not an accident. It's designed so that when you use our conversion formula, the pi from your angle and the pi in our formula just cancel each other out. It makes the whole calculation so clean and simple. Okay, enough with the theory. Theory is great, but let's actually see this thing in action. We're going to walk through 3 examples together, starting easy and then ramping it up a bit, just to show you how straightforward this really is. First up, a total classic. 2 pi over 3 radians. So, step 1, we set up the multiplication. We take our 2 pi over 3 and we multiply it by our magic key, 180 over pi. And look at that. Just like we said, the pi's on the top and bottom cancel out instantly. Beautiful. So now we're just left with some simple numbers. 2 times 180 divided by 3. A quick calculation, and we get our final clean answer, 120 degrees. All right, what if they throw a negative angle at you? Let's try negative 7 pi over 6. Does it change anything? Nope. The process is exactly the same. Don't let that negative sign freak you out. It just comes along for the ride. We multiply by 180 over pi, the pi's cancel out again, and we're left with negative 7 times 180 all divided by 6. Do the math, and you get negative 210 degrees. See? Easy. Okay, now for the one that sometimes throws people for a loop. What if you just get a number, like 3.5 radians, with no pi anywhere? The method still doesn't change. You just multiply 3.5 by 180 over pi. Now, the only difference here is that since there's no pi to cancel out, this is where you'll probably need to grab your calculator. You do 3.5 times 180, which is 630, then you divide that by pi, and you get an answer of about 200.5 degrees. Okay, this next part is super important. I want to talk about the one mistake, the one pitfall that catches almost everybody at some point. Seriously, knowing what not to do is just as important as knowing the right way. Check this out. This is the classic mistake right here. People just grab the wrong conversion factor. Remember, you're trying to get rid of pi to end up with degrees, so you need 180 on top and pi on the bottom. If you accidentally flip it and multiply by pi over 180, look what happens. You get this ridiculous answer with a pi squared in it. What even is that? It's not degrees, that's for sure. So just burn this into your brain. To get degrees, 180 goes on top. So at this point, you might be thinking, Okay, I get it, but why does this really matter outside of my next exam? Well, believe it or not, this conversion isn't just some random thing you do in math class. It's actually happening constantly, millions of times a second, in technology you use every single day. Just think about the GPS on your phone for a second. When you look at the map, it's showing you everything in degrees, right? Latitude and longitude, that's the language we understand. But the super complex calculations happening behind the scenes, the ones figuring out the shortest path on a curved planet, those algorithms can only work in radians. So your phone is constantly, silently translating back and forth between these two languages just to tell you when to make the next turn. All right, let's wrap this up with the 3 big takeaways. Number 1, to go from radians to degrees, you multiply by 180 over pi, always. Number 2, use this trick as your sanity check to make sure your answers actually feel right. And number 3, the absolute easiest way to remember the formula, you want the pi to cancel, so you gotta put 180 on top. Simple. So I'll leave you with this little thought to chew on. Today was all about translating between radians and degrees. But it kind of makes you wonder, right? What other math languages are we translating all the time without even realizing it? Like when you figure out a 20% tip, you're translating a percentage into a decimal. Or when you're cooking and convert cups to ounces, it's everywhere.